Good evening, everybody, and welcome to another episode of vBrownBag. Tonight, we are covering this is the second episode of our AWS Professional Solutions Architect Certification Review series. And tonight, we're going to be covering disaster recovery with AWS. I am very excited to have Rick Crisci as our presenter. He is at vrick31, and we have got Cody Bunch, the father of vBrownBag, back on host duty. Hi, Cody.
Hello.
Please feel free to drop any questions that you have about tonight's episode on at vBrownBag or hashtag vBrownBag on the Twitters. We will get to them. Since this one is not being recorded with a live studio audience or peanut gallery, we will be getting to them as we run into them on the interwebs. So. Obviously, we are going to be putting the episode up on our YouTube channel and our iTunes channel. This is also our first episode being recorded with Zoom. So we're excited to see how the what was that feature, Cody? The transcript?
Yeah, transcriptions. If this works correctly, we should have like proper transcribed episodes. I say proper insofar as machine learning transcriptions can be proper.
We'll see how they mangle your last name, Rick. Cool. Okay, so without further ado, I am going to stop my share, and Rick, take it away.
All right. Thanks so much for the introduction, guys. So my name is Rick Crisci. I'm a VMware certified instructor and an AWS official instructor as well. And so I'm glad to be here presenting this topic. A little bit about myself.
Oh, you're not sharing your screen, Rick.
Oh, I'm going to share it now. There we go. Thank you.
Bam, got it.
A little bit about myself. I've been an instructor for about 5 years, but I've been in the IT industry for closer to 20 at this point. This is my website, trainertests.com. And all of the content that I go through today is actually part of some of the live courses that I deliver. So if you're interested in taking a live course with me, just go ahead and visit my website at www.trainertests.com. And also, please feel free to connect with me on LinkedIn. I always love to have people connect up with me and
awesome.
Connect via LinkedIn. So please feel free to do so. All right. And with that, I'm actually going to go ahead and just roll right into the content here. So we're going to learn about disaster recovery, backup, and restore with AWS. And what I'm really going to focus on here is some of the stuff that you can expect to see on your AWS Solutions Architect professional exam. So we're going to be teaching it from a standpoint of preparing for the exam. And so as we kind of go through these slides, we'll start out with a little bit of an introduction to some critical concepts that you need to understand in order to successfully facilitate disaster recovery with AWS. So we'll kind of lay a little bit of the groundwork on these first few slides. And I apologize in advance because I don't like to do this, but the first few slides do have quite a few bullet points on them. So we'll try and roll through those relatively quickly here before we get to all the diagrams and animations and stuff like that. But there are a few things that we gotta know before we can start on disaster recovery. We have to understand some basic concepts like recovery time objective and recovery point objective. So these are a couple of the terms you'll hear me use frequently throughout this session. Recovery time objective basically governs, how fast do we need to be back up? If we have a disaster, if we have some kind of massive failure, how much downtime can we tolerate? That's our recovery time objective. Our recovery point objective governs how much data can we lose? How much data loss is acceptable? Do we need to be able to restore to 5 minutes ago, or can we tolerate up to 24 hours of data loss? That's going to impact our recovery point objective. So this is really the starting point. If you're designing, it doesn't matter AWS or anything else, any kind of disaster recovery solution, this is the starting point, is you have to identify the deliverables, right? This is what I need, my recovery point objective and my recovery time objective. And that's really going to drive which solution we choose. Because kind of like anything else in IT, the shorter the RTO and the shorter the RPO, the more expensive the solution gets. So we have to know what we need up front, and that's really going to drive our design decisions moving forward. So RTO and RPO are kind of the first really critical terms, and there are a few AWS technologies that we need to be very familiar with as well. So starting with S3. So many of you have probably used S3 at this point. If you're attending a professional class, you've probably dealt with S3 a little bit. And S3 is, our object storage within AWS. It provides 11 nines of durability. So it is extraordinarily durable. And here's a quick example of pricing. I am noting a few of the prices, just understand these may change over time, but I am noting a few prices as we kind of move through here, because I want you to have a comparison of the different backup options available. So in this case, we've got the S3 standard tier where we're going to pay about 2.3 cents per gigabyte per month. That's kind of our starting point here. And S3 is our object storage within AWS. So it comes with certain features that are really ideal for backup storage. Right? We've got lifecycle management, where we can store data inside of S3. And then after a certain time period, we can automatically migrate that data to a different pricing model, like S3 infrequent access. So you can see with infrequent access, we're paying about half the price as we pay with S3 standard. So that's the beauty of the lifecycle management, is the fact that, as data gets older, we can transition it to a less expensive storage option. And that really kind of helps us to keep our costs down long term. And we can also enable versioning. So versioning gives us the ability to do incremental updates, right? So we can have different restore points for the objects stored in S3. That's what versioning is all about. So of course, with versioning, there's going to be a cost. And with versioning, what you're really paying for is you're storing multiple versions of objects inside of S3. So of course, there's a cost associated with that. And then here's another thing that's important. And by the way, when we wrap up this session, I'm going to share a link to a document on the AWS website with you. Everything that you're seeing here is basically inspired by the AWS documentation and closely aligns with what you can expect on the exam. So just kind of heads up is kind of the reason why I'm covering some of the things I'm covering, like MFA delete.
Actually, if you give me half a second to interrupt you here, on the versioning point, is that similar to how like documents are versioned in in Dropbox, or is that closer to how like source code is versioned in GitHub?
So essentially, what it's like is, let's say here. Let me give you a quick example. So let's say that I go ahead and I place an object into S3. Right, here's my new object that I've just gone ahead and created in S3. And then, a month from now, I say, you know what, I need a new version. I made some changes to that object. What happens is a new version of that object is stored in S3, right? So let's call this one here version 1, and let's call this one here version 2. And S3 is basically just tracking which one of those versions is the current version of that object. So S3 knows, okay, version 2, this is the current version of that object. And so if anybody goes to access that object, they will get version 2. And kind of on it goes. The more versions you store, obviously the more space it takes and the more expensive it gets.
Okay. All
right, so I'm going to clear that out. So yeah, so versioning is obviously an important part of this because it gives us multiple restore points, right, for that data that we're storing there. And then finally, MFA delete. I'm not going to go too deep into this, but what this essentially means is if we store an object in S3 and somebody decides to delete that object, it's going to require multi-factor authentication in order to perform that delete. And the logic behind that is, let's say we're storing backup data inside of S3. Well, we don't want somebody to accidentally delete our backups, right? So that's why we may want to consider MFA delete to ensure that that doesn't happen. Or we could also consider just going with, let me get rid of my annotation here. We could consider going with Glacier instead. Right? Now, Glacier is going to give us the lowest possible cost out of all of these options. You can see here, lifecycle management, under lifecycle management, even infrequent access was still about 1.2 cents per month. Glacier is 0.4 cents per month. So you can store a lot of data really inexpensively in Glacier. And within Glacier, the data is stored as an archive that's encrypted. The big kind of drawback of Glacier is it's going to take time. If you need to get your data out of Glacier, it may take even a couple hours to retrieve that data from Glacier. So just understand there is a drawback with that. It's going to potentially take some time to get that data out of there. But if you need to store a massive amount of backup data, you really can't beat the price here. And Glacier does also support something else. Let me just mention this real quick while I'm on the screen. Glacier supports something called a vault lock, which you may know better as write once, read many. Right? You might know that better as write once, read many. Vault lock essentially allows you to store some data in Glacier and lock it so that it cannot be modified, which is important for a lot of different regulatory requirements. So that's kind of just a quick overview of S3 and Glacier, or at least the parts of it that you need to know from a disaster recovery perspective. We're kind of thinking of S3 as our primary backup solution, especially since it's low cost and it has 11 nines of durability. And let me clear out my, there we go. Okay, so another option, Elastic Block Store. So you may know EBS as, this is sort of like the volumes for your virtual machines, right? Or your EC2 instances, I should say. These are the volumes for your EC2 instances. And if we take a snapshot of an EBS volume, it's going to be stored in S3 with that same 11 nines of durability. So EBS snapshots are very durable, just like anything else stored in S3. You can copy them. Sorry, my bullets are out of order there, but you can copy them to another region if you'd like to do so. So you can take a snapshot. Let me kind of talk this out real quick. What we could do with AWS and disaster recovery, we kind of have to think about a few different scenarios, right? We may have an on-premise data center that we're worried about failing, or we may have AWS resources in a certain region, right? And we may want to consider the possibility, even though it doesn't happen very often, that that entire region could be down. So in that case, it could be helpful to say, hey, I've created this EBS instance, or this EC2 instance, I'm sorry, running in one region. Maybe I'll want to then go ahead, snapshot it, and copy that snapshot to another region, just in case I need it, just in case region 1 completely fails. So
just in case all the AZs all over the entire region, they all go down.
Yeah, and like I said, yeah, it doesn't happen very often, but we have had region-wide outages.
That is true.
Yeah, as recent, I think about a year ago was the last one. So yeah, it doesn't happen often. And when it does happen, it doesn't typically last long. So by the time you actually execute your DR plan, there's a pretty good chance the original region will be back up anyways. But just something to bear in mind, depending on what your RPO and RTOs are.
And as far as planning for that goes, like, is there a cost for copying between regions, or maintaining in separate regions, or say changing your primary from US East 1 to London or something of that nature?
Yes. Yeah, and understanding the costs of all this stuff is probably the most complex part of DR with AWS, to be honest with you. Understanding every little thing that you're charged for and not charged for. But a good rule of thumb to kind of bear in mind for the pricing is, if you're transferring data out of a region, whether you're transferring it to the internet, whether you're transferring it to AWS, a different region within AWS, you're probably going to be charged for that data transfer. And so transfer out of a region is something you're typically charged for.
Okay, and for the exam takers amongst us, like, is designing around pricing or pricing considerations something that comes up in the exam? Like, I know it's not a DR topic, but is it something that should permeate most of my study, or?
I wouldn't say it should permeate most of your study, but you should have an awareness of basically the kind of stuff that I just said, what sort of things you're charged for, what sort of things you're not. You don't need to know, that EBS snapshots are charged at 5 cents per gigabyte per month. But you have to have an idea that, hey, if I'm taking a snapshot of an EBS volume, number one, it's stored in S3. And number two, I'm going to be charged for that at a specific rate for an EBS snapshot. Yeah, hopefully that helps. There's a lot of pricing stuff that really you could just. I know consultants that's really what they do, is just AWS cost reduction. So
it's a lot of what I do.
Yeah. So there you go. So those S3 snapshots, they are stored, or I'm sorry, the EBS snapshots are stored in S3, but you'll notice you're paying about 5 cents per month per gigabyte of data. So they're charged at a significantly higher rate than just your regular old S3 data. So bear that in mind. But if you need to take a snapshot of an EC2 instance, this is a way that you could do that. And you can copy it to another region as well. Right. And just another side note for the exam, if you ever run into a question where you need to move an EC2 instance from one region to another, this is how you do that. You take a snapshot of it, you copy the snapshot to another region, and you use it to create a new instance. You can never just move an instance from one region to another. Okay, we've also got the import-export disk option. So this has been around forever. Basically, what you do is you put your data on a physical storage device, you ship it to AWS, and typically the day that they get it, they start transferring all of your data into either EBS or S3. They're kind of pushing more towards the Snowball physical appliance at this point, but if you choose to do this, you're going to pay an $80 fee per device handling, as well as whatever it costs to actually load the data in there. But for the exam, what I would really be aware of is, yes, I can load my data onto a physical device, physically ship it to AWS, and they can load it into either S3 or EBS for me. And that's kind of the use case, is to seed our data and get our data into the AWS environment. And then maybe we can make incremental changes from there.
And then Snowball, like, they have, they're all the way up to like 18-wheelers now, right?
Yes. Yeah. Yep. Yeah. So there's different. Yeah. They'll basically send an 18-wheeler truck to your location. As you can imagine, I don't even know what the cost is for that, but I imagine it's pretty high. And yeah, you load all your data up into it, and then they drive it to an AWS data center. Yep. Yeah. Whereas the Snowball appliance is definitely more reasonably cost, and it's just this hardened physical device that they'll ship to your business. You hook it up, you load all the data onto it. The data is encrypted. It's very standardized, and then you just kind of send it on its way. You can request that right within the AWS console and get them to send one to you.
Awesome.
Yeah, so we can import and export our data physically. And then another option that's important to understand for disaster recovery perspective before we kind of get to the 4 different DR models here is the storage gateway. So first off, we've got storage gateway cached volumes. And we want to kind of focus on that word cached, right? Cached volumes. So here's what we're going to do. Our data is going to be written to S3. And that's where our data is going. It's permanently stored in S3. That's really our storage. Our storage solution is S3. But we've still got some kind of on-premise physical storage. So what we'll do is we will create ourselves a virtual machine and we'll attach that local storage as virtual disks for that virtual machine. That's going to be our storage gateway. And in this model, what's going to happen is our data is going to be persistently stored in S3, but we're going to keep a local copy on our local storage system of the most frequently read data. So that way, it's like having a locally cached copy of our most valuable data. And so this is going to help us kind of get the performance of an on-premise storage array without necessarily having to always scale, right? Because we know how expensive, scaling on-premise storage can get really expensive. Kind of keeping up with the VM sprawl and all of the needs that we have for physical storage may become cost prohibitive at some point. So maybe instead we want to just kind of put all our data in S3, but just store the most frequently utilized data in our array at our physical location. And we can even take EBS snapshots of these storage gateway volumes so that we can have incremental backups or multiple restore points, I should say. Right, so remember, when it comes to the exam, storage gateway cached volumes, right? In that situation, your data is persistently stored in S3, whereas with our other option, storage gateway stored volumes, it's a little bit different. Right? With storage gateway stored volumes, your data is all stored locally. This is like essentially taking your storage capacity that's on-premise and continuously backing it up to S3. That's storage gateway stored volumes. And as you can imagine, this is a pretty attractive disaster recovery solution because now all of the data that's on my local storage appliance is going to be constantly backed up to S3. And again, we're going to have to create a virtual machine on premise. That's going to be used as a virtual storage appliance. But we have that option there to use a storage gateway with either stored volumes or cached volumes. And again, we can take EBS snapshots of the data that we're storing. So that gives us that incremental backup solution and multiple restore points. Okay, so now let's kind of dig into some of the nuts and bolts of this thing. Let's assume that we are dealing with, I've got all my resources in AWS Region 1, and I'm going to kind of consider AWS Region 2 as my disaster recovery option. Right? So that's where I'm going to spin things up if Region 1 fails. And inside of Region 1, I've done all this work, right? I've created VPCs and I've created elastic load balancers and auto scaling groups, and all sorts of other stuff, like IAM roles and things like that. And here we've got some EC2 instances running, and those EC2 instances are using EBS volumes to provide virtual disks to those EC2 instances. So if I want to restore to AWS Region 2 in the event of a disaster, I've got to first establish this whole infrastructure again. I've got to have VPCs created there. I've got to have elastic load balancers and auto scaling groups and all of those things that I went through the process of creating in Region 1. I have to somehow replicate that, right? I kind of think of it this way. Forget about AWS and all that stuff for a moment. Think about 2 physical data centers. Well, if I have a disaster recovery location that's a physical data center, I can get as many servers going as I want. If I don't have routers or firewalls or load balancers or any of that other stuff, those servers aren't going to do me much good, right? And that's kind of like AWS. We've got to have this infrastructure here to provide us with connectivity and control and all these other things before we can start, restoring our backups and getting our EC2 instances up and running. Right? So that's kind of the precursor, right? It's to have that other region built out. And then the next thing that we'll do is we'll kind of say, okay, I've got, an EC2 instance that runs a web server. And I know that if I have a failure, if I have a disaster, I'm going to want to run that web server. So let me create an AMI based on that web server and store it in my other AWS region. And now, if I do have a disaster, if I need to get one of those web server instances up and running, I can spin up a new EC2 instance based on this AMI. And the AMI is based on a snapshot of the root volume of this EC2 instance. So anything that I've configured on that EC2 instance in that root volume is going to be baked right into that AMI. So if you're kind of more comfortable with, traditional virtualization or traditional servers, think of this like an image, right? I've already created my perfect instance here. I've already kind of been through the ringer with this thing and have set it up exactly the way it needs to be. I'm capturing a complete image of that instance, and I can copy those AMIs to another region if I want to. So now if I do have a disaster, I've got an image that I can work from there. Right? And even if the image is 3 months old, I can use the image, the AMI, to spin up a new instance, and then I can use whatever my backup solution is to restore the latest data to that instance. So having those AMIs kind of play a big part. And as we look at the different kind of disaster recovery methodologies here as we move on, you'll see these AMIs are a part of just about all of them.
Okay. So to make that or put that in terms, maybe I'm a little bit more familiar with. That's the same as like I create a golden VM image at some point in time and then restore my most current data to it at a later point in time. Is that?
Yeah, absolutely. Okay. Like if you're a vSphere person, it's like taking a virtual machine, making an OVF template, and putting it at your DR site. You can always spin up a new VM based on that OVF and then restore the latest data to it from backup. That's kind of like an AMI. Very similar concept.
Awesome. Okay.
Cool.
All right. So let's kind of move on here to the next slide. Okay. So AMIs are also, of course, a big part of this. And then we've got CloudFormation. CloudFormation is, I want you to kind of think about CloudFormation when it comes to DR. CloudFormation is kind of like your DR runbook. If you've worked with a disaster recovery runbook or a recovery script or something like that, that's what we can use CloudFormation for. So if you've never used CloudFormation, it is an extremely powerful tool. You'll create something called a template. And what the template is going to govern is all of the AWS resources that need to be created can be automatically created when you execute a template. Like, so for example, let's say that our AWS region 1 is down, right? So let me back up a little bit. So we had VPCs, we had elastic load balancers, auto scaling groups, all of that kind of stuff. EC2 instances running and volumes and all that good stuff. And now that region 1 is down. You say, well, we want to get, our website back up. We want to get our resources back up in AWS region 2. We could have a pre-created CloudFormation template. And by the way, the CloudFormation template could be based on exactly what we have here in region 1. We can have a CloudFormation template that we use to deploy everything in region 1, and we can just use that same CloudFormation template in region 2. And there's all kinds of tricks to this. I'm not going to get too deep into the CloudFormation side of things, but you can use like variables and conditions and stuff like that, so that in AWS region 2, you can use the exact same CloudFormation templates to create the exact same type of environment. So it's a seamless sort of transition. Now, it's also good for creating like a test and dev environment as well.
Right. CFTs are incredibly powerful. Right now, they're my favorite thing.
Yeah, they're great. They're great stuff. Absolutely. Yeah, CloudFormation templates, basically the AWS line is they allow you to treat your infrastructure as code. So if you want to make some changes to your VPC, you'll update your CloudFormation template and then roll out those changes. And if you need to go back, you can just go back to an old version of the CloudFormation template and go back to the exact same way that things were. So think of it as like a data center in a script, right? That's essentially what it is. It's cool stuff. So anyways, let's say AWS region 1 goes down. Well, now I can just execute my CloudFormation template, have it roll out, VPCs, load balancers, auto scaling groups, set up alerts in CloudWatch, set up S3 buckets, set up EC2 instances, launch them based on AMIs. It can do all of that stuff in a scripted, automated fashion for me. And that's going to bring my RTO down, right? Rather than having to manually do a bunch of stuff. I can kind of take this as far or do as little as I want. But if I have manual tasks that I know are going to need to be performed in AWS during a disaster, you want to kind of think about those manual tasks. And this is kind of a sidebar thing, but having been through a disaster before and having to recover from it, I can tell you that like most of the people at the organization that I was working with at the moment, I kind of panicked a little bit, and it's not like the DR simulations that you have in the meeting room. People kind of freak out and everybody's asking you for a million different things. And, you have users saying, I don't have my shortcuts on my desktop. Well, that's not really a priority at the moment, but really in that moment, it's a kind of a nice, warm, fuzzy feeling to say, hey, I've got this script. I can just run, right? I've already tested it. I've already validated that it's going to do exactly what I need to do. Let me just fire off this CloudFormation template, let it go out there, deploy all these resources for me so that I can, go give an update or something like that. So you kind of want to think of these as if there's anything manual that I need to do in AWS in a DR situation, I want to bake those things into a template, CloudFormation template, so that I don't have to do them manually in a disaster event.
Okay, so maybe we'll not exam specific, but at a very high level, very naive level here, it sounds like you just described like the analogous, the AWS analog to SRM minus maybe some automation or auto detection pieces. Is that like,
absolutely?
How does this fit with something maybe I'm familiar with?
Yeah, that's a great comparison. Very similar to SRM. The only difference that you kind of want to think of is, and I'm coming from a VMware background myself, kind of going into this with a VMware bias initially and say, well, I could do this in VMware. How can I do this with AWS? And that's where CloudFormation really kind of jumped out to me, is this can replace SRM for me. It's going to require a little bit more, manual intervention on my part. I'm going to have to get to know how to actually write these CloudFormation templates. But I can set up a CloudFormation template to basically do everything that SRM would have done for me, from creating static IPs to whatever I need to do. I can bake it into a set of CloudFormation templates that'll run at my recovery site. Yeah, so it's basically an SRM. I mean, it's useful for so many more things than that. So I don't want to kind of say, hey, this is the SRM for AWS, because you'll probably use it to do a million other things like, production and test and dev environments and revision control with your infrastructure. It gives you a whole lot of capabilities outside of DR.
Correct. Yeah,
But
there's a lot more flexibility to it than just SRM stuff.
Yep. But
Okay.
if you're looking to replace SRM, this or SRM equivalent, this is what you would use for that.
Cool.
All right. So let's see here. So let me go through just a little bit more stuff here before I start getting to the 4 DR methods here. So kind of got to lay the foundation here. Another option that we can use is VM import export, which is a relatively straightforward process. What you're going to be doing is potentially, you're in a VMware environment or Hyper-V or Citrix Zen, and you want to start to take your virtual machines and bring them into AWS, right? So kind of the rule of thumb with AWS is you don't pay for transfer in, right? But you pay for transfer out. So they want to make it very inexpensive or free to get in, because of course they want you to get in. So you can import all of these things. Now, if you're going to run your virtual machines as EC2 instances, of course you're paying for EC2. If your instances have volumes, you're paying for EBS. If you're storing objects, you're going to pay for S3. But other than that, there's no charge for import export. So you can import and export your virtual machines at no cost. And what this gives you the ability to do now is, let's say it's kind of like an OVF template, right? If you're used to VMware, it's kind of like an OVF template. You've got all of these virtual machines that have been imported as EC2 instances, and at that point you could just shut them down, right? No reason you can't do that. So then you're not really paying for EC2 so much anymore. You're still paying for the storage you use. You could just shut those instances down and then have them sitting there ready to go. And in the event of a disaster, you can very quickly launch those instances and then start restoring from backup, right? So this is kind of like having a bunch of, shut down servers at a disaster recovery location. And you don't really touch them very often, but maybe you have a practice of every 3 months or once a month or something, you boot them all up and you restore them from backup or something like that, just to kind of keep them relatively fresh. So again, it's not just a disaster recovery tool, kind of like CloudFormation. This is a great way to kind of start transitioning into the AWS cloud, but it's also very useful for disaster recovery. And in order to do this, you'll have to use the AWS CLI to actually import those virtual machines into S3.
Okay. Rick, I just wanted to, we are getting within like 10, 12 minutes of the hour mark. I just wanted to give you a little bit of a, we're coming up on that.
Okay.
We do try to keep the episodes at around an hour, but if we need to run a little long, that's okay. Just wanted to, because this is our first one on Zoom. I don't really know how all the various bits and bobbles are going to work logistically yet.
Okay.
So.
Okay, no worries. I'll start picking it up a little bit here. No problem. I like to talk a lot, as you guys are probably realizing now. So I'll talk a little faster.
No, this is all great stuff. This is fantastic.
Yeah, great. Okay, awesome. So this is one of the slides then that for the sake of time, I'm gonna gloss over really quickly here. But here's kind of our traditional, we had a primary physical site, we had a recovery site. This is where I normally go through kind of what disaster recovery has traditionally looked like in a data center when I teach this class live. But and typically we have some kind of storage replication, as you can see at the bottom there. But let's get into these 4 topologies, because these are really critical parts for the exam. And now you've kind of laid the groundwork, right? That's what we've been spending most of our time doing, is laying the groundwork for these 4 topologies. So if we understand everything that's come kind of before this, it makes it really easy to understand these 4 topologies. And so first up, we've got backup and restore. And what we're looking to do in this situation is basically the data that we're storing on premise, we want to back it up to S3. And there's a lot of different ways that we can go about this. There's solutions in the AWS marketplace that we can use, like Cloudberry is a good example. There's a whole bunch of them that we can use to back up our virtual machines and store those backups in S3. And then in that situation, right, if that's the solution that we're using, now we're going to want to say, hey, we've got these critical servers. Let's create AMIs of those critical servers in our AWS data center. Maybe I'll use VM import export to create shut down EC2 instances. But I'm going to somehow have images of those critical virtual machines in the AWS data center. But I don't have anything running, right? This is the backup and restore model. So I don't actually have anything at all running in my AWS. Think of AWS as kind of like a cold site where nothing is running. And then, of course, critical to all this, and you're going to see this on every slide deck from here forward, is you have to test this plan regularly, right? Absolutely critical. But what we'll then do in the event of a disaster, right, the primary site is down, we use our AMIs to go ahead and launch EC2 instances. And once our web server is up and maybe our database servers and our application tier and all of that stuff, we'll go into Route 53 and we'll update our DNS records to point to our recovery site. And there's a few different ways that we can do that that we'll get into here as we get a little bit deeper. But that's kind of the basic gist of it, right? So what you want to remember for the exam is with the backup and recovery model, I don't have any instances running in my AWS environment. I've got a data stored there as backups, and that's really it. I might have some images so I can quickly create EC2 instances, but I don't have any instances running. I can even use Amazon Workspaces to provide virtual desktops. So that's what my restore process is going to look like, right? I'm going to launch new instances. Maybe I'll create some auto-scaling groups or elastic load balancers. Maybe I'll use CloudFront to speed up the delivery of content on the web. Maybe I'll use CloudFormation to kind of create a script for everything that needs to be launched. And then I'll restore all of my data from backup, and I'll repoint DNS so that we start using the new location, the new web server. So that is the backup and restore model, right? And we think of the backup and restore model, that's the worst performing from an RTO perspective. That's the one that's going to take us the longest to get everything up and running. Whereas with Pilot Lite, again, everything's going to be very similar, right? We're going to be backing up our data to AWS. We're going to create some AMIs of our critical instances. But then in this case, what we'll do is we will kind of have a few little servers running and inside of that Pilot Lite, inside of the Pilot Lite site, right? So slightly different here than the backup and restore model. It's very similar, but just a little bit different, right? And the big difference that you kind of want to bear in mind for the exam is this is kind of the where AWS sort of draws that line. They've got a database at the primary site that is replicating to a database inside of the AWS data center so that I have synchronous replication of data. Right? So that this is going to give me a much better recovery point objective, or RPO, because my data is going to be synchronized in real time. Right? That's the line between backup and recovery versus Pilot Lite. I've got that synchronous replication of data, and then I can use my AMIs to quickly launch instances that leverage that live data. So not only is this going to help from a recovery point objective because I've got a current copy of the data, but it's also going to help with my RTO, right? Because it's going to take steps away from that recovery process. And then the final step is once I've got everything up and running, I'll update Route 53 to point all my traffic at the recovery site. Now, the other thing that I'll just mention, I could use Route 53 failover routing, right? So Route 53 could be constantly performing a health check. And when that health check fails, it could automatically redirect traffic to some other resource. You can do this with AWS web servers. You can do this with on-premise web servers. Right? Route 53 failover routing could be used to automate the redirection of that traffic. So that's just another thing to bear in mind. And when it comes to DR, I'm all about automation, right? Anything that we can possibly automate is a good thing. So now you'll notice there's one big step that's missing that we had in backup and restore. You know, in Pilot Light, we're going to start up our instances based on AMIs. We might need to resize resources, right? Maybe we need to make our database a larger instance type or something like that, so it can handle that production workload. And then repoint DNS, right? We don't have to restore any backed up data. So this is going to improve our RTO, right? And then one step that you just sort of need to think about, and those of you who have used SRM are very familiar with this, reprotect, right? If we've had a disaster and our primary site is now down, at some point in the relatively near future, we want to start backing up our DR site, especially if it's going to be a long-term situation where we're using it. Okay, so two more models here to take a look at, and then we'll wrap it up here. I'm standby.
One quick point of clarification. As we go through the models, the RTOs are going to be getting better and better, but the price points are also going to be increasing as well. One of the things that I saw in the exam was a distinction where you needed to know something along those lines.
Yeah, absolutely, that's correct. Because if we just look at the Pilot Light model, now you're running a live database full time, right?
Right.
Where we weren't doing that in backup and restore. So, yep, our costs are already starting to be increased. Yep, absolutely. Yeah, that's a great point. And with a warm standby, yeah, we're running a database. We're replicating that data in real time. And this is, again, the model of kind of like a multi-tier application with a web front end. And so not only do we have a database running full time, but here you can see a little web server and a little app server that are actually running full time. Okay. So now, of course, our costs are going to increase because we're running EC2 instances all the time and a database all the time. But what we could even do now in this situation, and this is the one that starts to make me sleep well at night, right? I like to always have, you know, some traffic hitting my DR site. That's just my personal preference. I like to have some traffic hitting it all the time. So what we could do is we could use weighted routing in Route 53 to maybe send 90% of the traffic this way and the other 10% of the traffic this way. And now we'll constantly be basically sending a little trickle of data into our low capacity standby. And so that's sort of the beauty of this approach is everything's already running that I need. You know, everything's already running, but it's running in a really limited fashion. I've got really inexpensive EC2 instances that are very small, and there's no way that they could handle the full production workload right off the bat. But they're running it full time, and I know that everything's working. And if I need to, here's kind of my personal approach. You probably won't see this on the exam, but what I like to do is I'll go ahead and put these in an auto scaling group, right? With a desired capacity of 1. And if the workload starts to increase because we fail over, auto scaling will just take care of it for me by creating more instances. But one way or another, if you do have a failure, if you do have a disaster, you're going to have to scale these up. And that's where the RTO gets, it's obviously much better than Pilot Light, but that's where your RTO is going to come from. Right? It's going to take time to build this thing up to full capacity. It's a low capacity standby. It's going to take time to get it all the way up to full capacity. Right? But now everything's kind of automatic for me. Right? I can use failover routing with Route 53. Auto scaling can build everything up to handle that production workload. Right? So it's going to lower my RTO, but it still takes time to reach full capacity. The only thing that's not going to happen automatically is if I have a small database, a small RDS instance. I may need to scale that manually, or I might need to create some read replicas or do something there to improve the performance of my RDS instance. Or maybe I just kind of take the RDS instance and bite the bullet, and pay for a full capacity, fully sized RDS instance. And like I said, we'll use weighted routing in Route 53 to trickle a little bit of traffic into AWS. So kind of here you see that example, 90% to the primary site, the other 10% to AWS. And we can bake failover routing right into that. So that if the primary site fails, now 100% of the traffic will go to the AWS deployment. All right, and here's the Cadillac solution, right? This is the most expensive. This is going to require the most running resources in AWS, but the recovery time objective and the recovery point objective is very low, right?
Seconds.
Yep, seconds, exactly. We're replicating data in real time. We have AMIs of our EC2 instances. We have a full capacity of web servers, app servers, whatever we need running there, it's running already at full scale. Let me clean up my ink. And so now what we could do is we could say, hey, Route 53, send half the traffic here, send half the traffic here. And my primary site is built out a little bit bigger than it needs to be, just in case the AWS side fails. And the AWS side is built out bigger than it needs to be, just in case my physical data center fails. So now, either one of them can take over within seconds automatically. Right? The only thing that needs to happen is Route 53 needs to fail over. Right? So as long as it takes my Route 53, and you can tune all this stuff, but as long as it takes Route 53 to perform a health check and say, okay, perform a health check here, this guy is down. Now let's send 100% of the traffic to an elastic load balancer with all these web servers behind it. Right? That's how long it's going to take to fail over to your recovery site. So full capacity, is like the Cadillac version. It fails over very, very quickly. There's no scaling required. There's no manual intervention required. It just happens, right? Failover routing is automatic. You don't have to scale, and it's got the lowest RTO. Right? It's also sometimes called full capacity standby. And that's the final model here. And real quick, before I'm going to stop sharing my screen just for a moment, but what I just want to show you guys one last thing here, and then I promise I'll stop talking. The document that I would suggest if you're planning on taking the professional exam, there's one document that I would recommend you read. Take a little time to read. It's called, here, let me share out my screen one more time. It's called Using Amazon Web Services for Disaster Recovery. You guys are seeing that share, right?
Yes, we are. Okay,
great. You can see it's October 2014, but this is still very closely aligned with the exam. And you can see all these options here, like backup and restore, warm standby. You can dig a lot deeper here. And you can see, a lot of the services that I was talking about, like S3 and Glacier and EBS and import export, those are covered here as well. Gateway cache, gateway stored volumes. So this is kind of the blueprint for the DR stuff that you're going to have to know to pass that exam. Right.
I would go so far as to say memorize this white paper, along with all of the other white papers mentioned in the exam blueprint.
Yeah, if you do that, you're going to pass. If you do that, yep. But
well,
yeah,
Yeah, you'll pass the associate, but the pro is trickier. Memorizing, that's the first stage for passing the pro.
Yep. Yeah, the pro is a challenging exam.
Awesome. Cool. Was that it, Rick? I don't want to tie you off too fast, but are we complete?
Absolutely. And I just want to encourage everybody again, if you want to connect with me on LinkedIn, or if you want to take a live class with me, just go to trainertests.com and you can find all my live classes, and feel free to reach out to me for promos or coupons as they may be currently available.
Awesome. Thank you very much, Rick. Thanks everybody for listening, and have a wonderful evening. And stop recording. Bam.